And if it's rainy, what do I get? 14, yes.
Can I ask you a question about the UI?
Yes?
On the base.
Yep.
Can you go back to the yeah, why is there a line between weather and
Because there's a line between every variable that share there's a line between every variables that are in a factor together. That's what this does. And the reason it does that is because it turns out that if you want to, what you want to do is to actually minimize the number of extra lines you add in. So the number of lines you add in is a measure of the complexity of this. So we try and, when we build, trying to do elimination orderings, we try and minimize the number of these extra lines extra variables that are in factors together.
So if we got rid of forecast, then there wouldn't be a line between weather and umbrella?
If we got rid of no, that's from the utility. There's a line between weather and umbrella because of the utility function. Okay, any other questions? Whoops, all right, let's go back to here. Oops, I'm lost. So that's what we've done here. So we just carried out this algorithm. We selected a random variable that wasn't a parent of the decision node. We selected the decision node. One of them was only in a factor with some of its parents. We eliminated it by maximizing this, returned an optimal decision function. So it returned both our decision function, which is this, and it also returned a new factor. And we're going to throw that factor back into our set of factors. We're going to keep doing that until there are no more decision nodes. So we're going to sum out, and then we're going to sum out the remaining random variables, and we end up with the expected value. So what happens? So this is the only factor left. So what happens when I sum this out? What number do I get? Who knows how to add? What happens when I sum out this variable? There's only one factor. What happens when I sum out this variable? What do I get? Who knows how to add? Oh, what is it? 28 plus 15 is that 77? 50. Right. This is the expected utility of that policy. This is the expected utility of the optimal policy. Let's close this. If I, whoops. I don't want to do that. I want this should be right. Oh, I made a mistake. So 77 was this value. And essentially we're going to, and we can change this policy. What might another policy? Maybe we're going to take it if the forecast is cloudy, so we can play with this. And if we change it, so here's my policy, forecast, sunny, I've got to choose. If I click it cloudy, I can play with this. Right, this is just this interface. Right, I can work out this. What's going to happen to the satisfaction? What's going to happen to the utility? It's going to go down, right? I don't know what it's going to be, but it's going to go down to 71. Okay, there are questions about that? Okay, let's do it for another one. Okay, so here's this node. So this is the other one we've been looking at that's quietly bigger. Right, so what are the rules? We create a factor for everything. So let's go back into optimized decisions. We'll do this verbosely. And somehow we're going to get this big enough so we can see what's going on. And my user interface is terrible, but that's okay. So what variables can I sum out? So I want to sum out a variable that's not a parent of a decision node. So start telling me variables I can sum out. Tampering, right? That's not. What else? The parents of a decision node were, oh, we can probably see it here too. Can I see this? Standard tampering. The parents of decision nodes were report, check smoke, see smoke. They're the only parents. Okay, so you can sum out fire, right? Fire is not we can sum out alarm, we can sum out smoke, we can sum out leaving. Right? And if you look at this, what happens is we end up here, and this is just the normal variable elimination before, we end up with this table here. Okay, so now we've got to the stage of which decision variable is only in a factor with some of its parents. Which decision? So there's two decision variables here, right? Oh, hang on. Can we just? Oh wait, I've lost it. I was going to do that. So which decision variable is only in a factor with a subset of its parents? Right, there are two decision variables, check smoke. Is check smoke in a factor with just a subset of its parents? It's in a factor. Are all the variables there a subset of the parents? What are the parents of check smoke or smoke? Right, what are the parents? Report. Right? So it's not just in a factor with the subset of its parents. Because there's other junk in there. There's see smoke and call. It doesn't know what to do because it doesn't know the value of see smoke and call. So we can't optimize, we can't do this same thing for check smoke. But what about call? Is it in a factor with the subset of its parents? What are its parents? Report, check smoke, and see smoke. Right. So we can eliminate call by maximizing. So call is going to have a factor. So then we go to call for every report, for every value of check smoke, and for every value of see smoke, we get to choose what to do, right? We get to choose what to do. So if they're all true, what do we choose? Oops, let's move this thing. I can get rid of that now, can't I? It doesn't like being quitted. Oh well. What do we do? If we report, we check smoke and we see smoke, what do we do? What should we do? We want to maximize utility. What do we do? Right, we're going to call. We're going to say call here is going to be true. And we're also going to construct a function, and the value for this is minus 1.33. So what happens when it's true, true, false? What are we going to do? If there is a report, we check smoke but we don't see smoke, what are we going to do? The call is going to be false. Because we get to choose. And the value here is minus 3.68. Okay, does that make sense? Yes. The reason we can't optimize check smoke is because we don't know whether it's because we don't have when we're going to check for smoke, we don't know the result of C smoke. Right? So we can't sort of optimize differently when we see smoke's true and false because we don't know that information. Right? We can optimize call because we know when we're going to call, we do know the value of report, we will know the value of check smoke, and we will value you know all these things. Right? But I can't optimize this for this table because if I do different things, whether I see smoke or not, and in fact, if you look through there, and if you're allowed to choose different things, it's always if you optimize this check smoke, it's always going to be false if you look at the different values corresponding to C smoke. Right, because if you can see the smoke, then there's no point in checking for smoke. Because you've cost something to check for smoke. So, okay, let's keep going here. Where am I going here? I'm going to eliminate call. I'm going to end up with this decision function, which is the one we saw before. Report, check smoke, C smoke, true. Thus all three are true. We're going to call if report and check smoke is true and C smoke is false, we're not going to call, etc. And there's also a factor. And then there's also a factor that has these numbers that we did before that we got from maximizing, minus 1.33, minus 3.68. So we did this by hand. Okay, any questions so far? Let's go back to our... Oh, let's go back here. All right, so here we're up to somewhere. Where are we up to? What are we going to do now? We've eliminated D by maximizing. There are still more decision nodes, right? So we're going to go back to we've got to sum out a random variable that's not a parent of a decision node. What should I sum out? Right, I'm going to sum out C smoke. And I'm going to end up with this value here with just report and check smoke. But now I can optimize check smoke because I know what to... Now I can optimize check smoke because I'm going to observe report. So if I observe report is true, what do? What's the best thing to do if report is true? I'm going to check for smoke. What if report is false? Well, I'm not going to check for smoke. So if I eliminate this, then you find that the policy here is to the one we just observed, one we just did. The factor here, we now have a functor on report. And now it's got to sum these together and we'll get the... Now we've got to sum out the remaining random variables. We've got to sum out report and we end up with the utility, the expected utility of this optimal plan. So it's just the same as we did before for belief networks. It's just we have this maximization step because we get to choose the best action, but we can only do it when we have the information that's available to us. All right, so next time so you now know enough to do the assignment. So next time we'll finish up this talking about value of information.